Good morning, good afternoon, good evening, and good night, friends and colleagues from across the world. Thank you for joining us today for our Sunday Podinar session. We have a very special guest today with us, and I'm honored to host Dr. Lamiaa ElFadaly of Egypt. Thank you for joining us today.
Thank you for having me. It's a great honor to be with you, Dr. Kenner.
Yes, I'd like to make an introduction shortly about your background and your topic, which is very exciting, artificial intelligence, which is affecting us in pretty much every aspect of dentistry and medicine now. But before I do that, some quick housekeeping stuff for our viewership and network. Like to invite you guys to the Doctors' World Gala, the first of its kind historic event in Sardinia, Italy. We've just opened up for registration. We are going to be honoring the classes of 2020, 21, 22, as well as 23, which will be announced later this year. We're expecting approximately 1,000 doctors of more than 120 countries that will participate in the gala and the conference operation with the Italian Dental Association. It's going to be a different kind of event than what we're used to in terms of the scientific session, the grand exhibition, the concert, the award ceremony, and specifically doctor networking of all of the class members and leaders of industry. So very exciting. Please feel free to go on. And if you're not part of a class, you're welcome to go to the website, congressaio.it, and also pre-register for the gala, and you can also register for the conference now with the Italian Dental Association. I believe you can get up to 30 CE credits with that scenario. So with that said, let's get started about introducing our speaker today. She graduated from she's actually from Cairo, and she went to the university in Cairo, finished her MSc in fixed prosthodontics in Cairo in 2005. And then she got involved with her PhD works, and she's mainly interested in digital dentistry and artificial intelligence in dentistry education. She is the founder of MSA Digital Dentistry Club, which was founded to spread digital dentistry education in Egypt and the Middle East, encourage research in the field of digital dentistry, and support entrepreneurship activity in digital dentistry. She has organized several events, so you guys may know her from conferences, where she brings in doctors and interns and undergraduates and leading doctors together to advance this industry. She's also the founder and board member of the first International Online Symposium, Digital Dentistry Secrets, Unleashed 17 to 19 September of 2020, that was attended by more than 8,000 dentists from all over the world. Very impressive, Doc. And I understand you're also participating with the leading ladies and many other organizations that we're friends with, and also a class member of the Top Docs. We very much look forward to meeting you in person in Italy. And an amazing career you've had, Doc. So what's your motivation?
Well, I love digital dentistry and I love AI, and I think it's the future. So I really believe that our young students need and deserve to know more about this. And to be more educated about it, because they will present to us solutions and things that we never ever thought of. So this is our role, to educate the next generation to have the advancement in our beloved professional.
That's a very interesting career path you have taken, because it's affecting pretty much every aspect in my clinic now. I'm in my 17th year of practice, and things have changed dramatically the last decade to a point where we currently have nothing but digital equipment in the office, from the CBCT to the scanner to the printer. It's all digital. So and AI is getting smarter and smarter.
Yes, that's true. And
What do
having
you what do you
go
see
on.
as
Sorry, I can't hear you.
What do you see us in 10 years? I see now robotics arms coming out that are working
Yes,
based on AI.
yes, I think so. Yeah, less than 10 years, we're going to have these robotic arms that are powered by AI, and our profession, the whole profession, the radiology will be powered with AI. The diagnosis will be no more a controversy. We have AI will affect every aspect in our field.
Yeah, so a diagnosis, a very, very important word. Diagnosis
Yes,
is not going to be an issue with AI. That's very interesting.
yes,
Where do you see
yes.
our place in 10 years from now as dentists practicing?
We'll have more time to deal what we have yeah, to do what we have to do, to deal with patients, deal with patients. That's our main job, not to be occupied with other stuff like having this controversy with the diagnosis and the treatment plan and this stuff. We'll only have to deal with our patient, and that's will be more relaxing for all of us.
That's good. That's good, especially if the accuracy of our treatments and diagnosis improves.
Yes,
That's a very good thing. Some argue
yes,
that they will eventually replace us in some capacity or another, where we're just sort of managing computers, and but I don't see that happening in our lifetime, at least.
no, not me. No, no, I don't think so. It will make our lives better, but not it's not going to replace us. And because we are the ones who invented this, and especially that our profession needs skills. I don't think that a robot can fully have these skills. You know.
Very good to know. So you're going to be talking about some examples about where AI plays a role now today,
Yes.
especially for a lot of our younger colleagues that are getting started. This would be great to hear if they're not already using it. I'm using AI on a daily basis to correct digital impressions and all sorts of stuff at the
Yes.
office. And
Yes.
this is very exciting. So tell us a little bit about what you're going to cover in your presentation today and what we can expect.
Okay. Well, first we'll talk what is AI. We need to know how it works. Then we'll talk about what are the opportunities and challenges that we have to really implement them in our lives. And then I'll give some examples about how artificial intelligence has being started being used and the research going on about artificial intelligence. We're still in the start of this era, but I think it will go more faster because we are all attending and we are all anxious to know more about artificial intelligence and to work with it and to learn about it.
Excellent. Well, Doc, I'm really excited to hear this presentation, and it's an honor to have you on the show. I'm gonna go
Thank you very
ahead
much.
and disappear in the background, and if you need me, let me know. Otherwise, the floor is yours.
Thank you.
Thank you.
Okay, thank you so much for the introduction and for the whole guesting me. And now I'll start my presentation. And my presentation topic is about artificial intelligence in dentistry, opportunities and the challenges. It's presented by me, Lamiaa ElFadaly. And as Dr. Kianor introduced me, I'm a PhD holder and I'm certified Hawaii Academy instructor. I'm also IBM certified and Microsoft certified. Now we live in what's called the fourth industrial revolution. It started in the 1700s when inventing the steam engine. Then by the 1800s by the invention of the electricity, and the digital era began by the 1980s. And now we live in what is called the fourth industrial revolution, where the blurring of lines between technology and our lives has happened by innovation of AI, 3D printing, robotics, and nanotechnology.
Was coined by the founder of the World Economic Forum, a former professor named Klaus Schwab. Schwab wrote a book with that title to describe an era marked by a technological revolution that is blurring the lines between the physical, digital, and biological spheres. Let's break that down. Technologies like artificial intelligence, autonomous vehicles, or the Internet of Things are becoming ingrained in our day-to-day lives and even our bodies. Think of voice-activated virtual assistants, Face ID recognition, or healthcare sensors.
Introduced in every aspect in our lives, and we use it daily. We use it in the recommendation of films. We use it in Facebook. We use it in our wearable devices like the smartwatch and so on. So what is artificial intelligence? Alan Turing said that the question is, can machines think? And John McCarthy said that it is the branch of computer science concerned with making computers behave like humans. And Marvin Minsky said that the science of making machines do things that would require intelligence if done by men.
While everyone seems to be talking about artificial intelligence these days, it's good to remember that this is not something new. In 1950, Alan Turing proposed the Turing test. That same year, Isaac Asimov proposed the 3 laws of robotics. The first AI-based program was written. In 1955, the first self-learning game-playing program was created. In 1959, the MIT AI lab is set up. In 1961, the first robot was introduced into GM's assembly line. 1964 saw the first demo of an AI program which understands natural language. In 1965, the first chatbot, Eliza, was invented. In 1974, the first autonomous vehicle is created at Stanford AI Lab. In 1989, Carnegie Mellon creates the first autonomous vehicle using a neural network. In 1997, IBM Deep Blue beats Garry Kasparov at chess. In 1999, Sony introduces Aibo. That same year, the MIT AI Lab's first emotional AI is demonstrated. In 2004, DARPA introduces the first building a self-driving car. In 2010, Narrative Sciences AI demonstrates the ability to write reports. In 2011, IBM Watson beats Jeopardy champions. That same year, Siri, Google Now, and Cortana become mainstream. In 2015, Elon Musk and others announce a $1 billion donation to OpenAI. In 2016, Google's DeepMind defeats Korean AlphaGo champion. In 2016, Stanford issues the AI 100 report. In 2016, UC Berkeley launches the Center for Human-Compatible Artificial Intelligence. As you can see,
let's compare between the human intelligence and artificial intelligence. This is the human intelligence, bodily, and the internet person. And during the intelligence technology landscape, we have also natural language processing. We have machine learning, deep learning, computer vision, and autonomous robotics. So let's talk about artificial intelligence in healthcare.
It's the symbiotic relationship between the human and machine that brings the magic of AI to medicine in a meaningful way.
Now we have the tools to make a huge difference to human life. cancer research, increasingly powered by data. Those data silo cross institutions.
We're creating data ecosystem that allows people to share data that still maintains the privacy of the patients.
With AI in healthcare has become so popular now, and thanks to the increased data volumes and the advanced algorithm and the improvements in computing power and storage. So what is the AI process? Well, to make a machine learning model, the model which is the program that we use to make an AI application, we start with data collection, then we clean this data, and then we make a feature extraction and selection. Then we train the model after feeding it with this data. Then we evaluate this model, then we deploy it and integrate it. And we iterate this process many times until we have accurate outcomes. So what are the opportunities and challenges to use artificial intelligence in healthcare? Well, we start talking about the challenges. The field of medical AI faces technical challenges as building user trust in AI system, composing the training data sets because we have a huge amount of data. So to train this data and to clean it is a challenge. The regulations of AI in medicines and the way in which AI may shift and create responsibilities throughout the healthcare system, affecting the researchers, physicians, and the patients as well. Also, what is very important is the ethical concern about data and the equity in medical AI to avoid bias, that all patients have to be presented and all patient categories have to be presented in our data sets. So what are the opportunities? The opportunities is, the main one is data. Data is called the new foil, the industrial revenue data. So data is exploding and no human being can keep track of all of it and make sense of it. By 2020, the amount of data created reached 44 zettabytes annually. And 80% of this data is unstructured, and we'll know what is unstructured is. And the medical data is expected to double every 73 days. The most significant elements of the big data in healthcare are the electronic health records, medical images, all the omics studies, the bioinformatics, genomics, transcriptomics, and the Internet of Things. Regarding the electronic dental records, 70 to 75% of the dental practitioners in USA are using it, as well as 90 to 95% of the practitioners in Scandinavian countries are using electronic dental records. Regarding the artificial intelligence in dentistry, well, dentistry is, as a branch of medicine, has not remained unaffected by the digital revolution. And the trend in digitalization has led to an increased computer-generated data in a growing number of dental disciplines. Well, dentistry is especially suited to apply AI tasks, although the convolution neural networks, for example, has only been adopted in research settings from 2015 only. So why AI is suited or mainly suited for the dentistry? We use imaging. We use imaging from diagnosis to treatment to conduct. In every step in our work, we use imaging, whether intraoral scanning or radiography with different kinds or photos. We use different imagery materials for the same anatomical region, for the same individual, accompanied with, again, with clinical records and dental history collected over multiple time points. And this makes us make a data that is a consistent data. AI is suited to integrate and cross-link this data effectively, and so we can improve the diagnostic, the prediction, and decision-making. And we have many dental conditions like caries, apical lesion, and periodontal bone loss, which are relatively prevalent, so we can build up data sets with high number of affected cases. So we have what is called the digital data. The digital data is either structured data or unstructured data. Well, the structured data like the patient's lab values, the diagnosis codes, things that we can put in tables. While the unstructured data are like the images or the natural language processing or the images with different kinds like radiography and so on. And this is how the computer sees the pictures. It sees like as pixels from 0 to 255 on the grayscale. And if we have colored pictures, it is transformed into the RGB, and then it is transformed to the grayscale and seen by the computer. Another form and another thing that we can take data from is the Internet of Things. The Internet of Things is a machine-to-machine communication technique. The Internet of Things is a domain that majorly involves in connecting sensors and other electronic devices to the internet. And these devices can be monitored and controlled from anywhere across the world. From the Internet of Things, we have what is called the Internet of Medical Things. It is a collection of medical devices and applications that connect to healthcare IT systems through online computer network. Medical devices equipped with Wi-Fi allow the machine-to-machine communication that is the basis of IoT. The best thing about Internet of Things that it creates a continuous stream of data while monitoring the health of patients and make these devices major contributors to the big data. And data generated by IoT devices is forecasted to generate 79.4 zettabytes by the year of 2025. Then we have what is called Internet of Dental Things, which are going to be a main source of data and of clinical examination. It is an innovative approach to achieve prevention and management of dental caries, periodontal diseases, oral cancer, and other dental disease, and it can play a vital role in collection and monitoring of patients. Examples of IoDT, smart dental health IoT systems that based on intelligent hardware, deep learning, and mobile terminal for detection of caries, periodontitis, cracked tooth, dental fluorosis, and tooth loss. Also, microbiological and evaluation using biosensors, and smart implants that are integrated in implants to detect micro displacement for implant-supported prosthesis, and also the Bite Force smart guards that are intraoral sensors attached to the oral appliance for evaluation of Bite Force measurements. Another thing is the dental monitoring, which allows the orthodontist to monitor orthodontic teeth movement and their patient's dental condition remotely, and the AI system then remotely verifies and tracks the movement of each tooth with both fixed appliances and clear alignments. And this is how it works. It can alert providers of common orthodontic conditions, including distorted or broken brackets, worn down or missing attachment, the condition and position of separators or band, and unseating of aligners. And the dental lines claim that it can monitor almost 180 dental conditions. Also, remote oral behavior can be done using the smart toothbrush. So all this data is collected and then it is transported through the cloud to the domain expert and to the clinician or the IT system in hospitals. So there are challenges implementing an Internet of Dental Things, but mainly decreasing the energy consumption is one of the challenges because they are mounted to the human body, so it needs to be not to be recharged often. So with the presence of IoT, we need strong internet connection, which is like 5G, to transport this data. So the 5G promises to transform medical field by drastically increasing the amount and quality of valuable medical data that can be gathered and processed at high speed, from medical records to larger image film files from MRI or CT scans. A single patient can generate hundreds of petabytes of data each day, so we need strong internet connection to transport this data.
5G network has the potential to completely transform the healthcare sector. It can do so because of the high-speed connectivity that it brings to the job. Healthcare is already on the cusp of gigantic changes with the technologies such as AI, AR, VR, IoT, sensor, and other advanced technology ready to disrupt the sector as it has been so far. All it needs is high bandwidth that can support the movement of the immense amount of data generated by all the devices and processes that are ready to be deployed.
We can use wearables.
To become a
we can use wearables. We can do home consultation, and also remote procedures can be done.
To become a reality. Robotic surgery is not quite new to the modern healthcare industry. However, at the moment, it is used with the doctors standing next to it. Can this be used remotely as well? The only weak link in this potentially revolutionary development is the slower internet. With the present level of the internet speed, you can't rely on a robotic surgery that would go off well in especially remote locations where the internet is sometimes not great. A remote robotic surgery would involve haptic feedback and image streaming on a real-time basis.
Using 5G. Another opportunity is the presence of open data sets. Like we have a lot of repositories that have huge number of data sets that can be used, like Kaggle and UCI ML repository and the Google Dataset Search.
First case. Like most image annotation or DICOM viewer, Darwin allows you to manually label things within images by making, for example, a polygon mask. However, as an AI platform, it also allows you to leverage AI to make these annotations autonomously. We use the auto-annotate, or N, as a shortcut to create segmentation masks automatically. Darwin tries to understand the objects you're encapsulated, matter lesion, and paints its pixels. You can click on a new area to include it, and as you'll notice, the accuracy of it is at a pixel level. You can also add comments on the images to discuss cases with your colleagues, or annotations if you're part of an annotation workforce.
Annotation is very important. So it eases the annotation of data sets by clicking and the time needed for it. And there are a lot of platforms used for this itself, and its algorithm and algorithm use deep learning in our discipline. And deep learning, it is mainly an architecture of neural network, and is inspired by the human neural networks. It is composed of subcategories. Deep learning can be convolutional neural network. It can be recurrent neural network or GANs. We'll start talking about convolutional neural network, and it is one type of deep learning that excels in image processing, and it has multiple layers, which are the convolutional layer and the pooling layer and the fully connected layer. So the purpose of the convolutional layer is to calculate and extract the features. Pooling layer is to decrease the amount of data and the size of data, and the fully connected layer to present the data or the features to the model. Another type of convolutional neural network is the UNet, which is used in segmentation. Computer vision, it is a subject that enables the computer to understand the image and video collected by the acquisition device, and it's specifically the computer is equipped by eye, which is the camera, and brain, which is the algorithm. The computer vision can do classification and localization, object detection, and instance segmentation. And it also can do image tracking. Another type of neural networks used in deep learning is recurrent neural networks, which is mainly used to evaluate and to work on videos and dynamic data. Something that recurrent neural network is used in is the natural language. And the natural language processing, it is the study of the computational treatment of natural human language. It enables machines to understand human communication to extract different information. So using machine learning and natural language processing can get us insights that we've never been able to capture before. One of the things in is the natural language is the IBM.
Hospital administrators think it's smarter than it really is. Patient fed into Watson. Second, the physician will ask Watson. Treatments that are obviously wrong. Then it scores and rank orders them by score.
Fed by many textbooks like PubMed and Medline, a large number of records of different patients from different hospitals and med symptoms and training cases and millions of notes. Another type of neural networks used in deep learning is the generative adversarial neural networks. So can you guess who is which person is real? Well, both are fake.
In this reel, you're going to see my amigo, Chris Umi. He's going to introduce to you the wonderful world of deepfakes, how AI and VFX are unlocking the future of our imaginations. What's up, TikTok? You guys cool if I play some sports?
So GANs can fake Tom Cruise, it can make diving portrait. And well, it was introduced by good and this is the model of the GAN. It is mainly made from two models, the generator model that is used to generate new example of the problem, while the discriminator model that is used to classify the example as real or fake. Some of the applications of GANs: generating photographs of human faces, and pose editing, changing 2D photos into 3D. And it can also edit the expressions. To image station. and it can change a 2D object into a 3D object. And we'll see how all of this can help us in dentistry. Well, in healthcare, GAN is also used. It's used in medical data augmentation. In case we don't have enough data, we can make new data with completely novel but realistic using GANs, as in case of using MRIs to make new CBCTs. And as you see in the second row, these are new data done by GANs to increase the amount of data used to feed our model. Electronic healthcare health records also can be generated using GANs by MedGAN, and designing DNA to optimize the protein function to give us desired properties. Also, designing drugs using GANs can be done using ChemGAN. Image segmentation using SegGAN can be used in medical images for detection of tumors, for instance. The last thing in our opportunities is the reinforcement learning, which is the algorithm that is provided by feedback, concern, and punishment as it problem is self-learning. Is mainly using so I and big data is what's called the prismatic.
100 milliseconds, how fast the drill is going, whether the chair is being moved, whether the water is on.
There are video cameras that are viewing the patients as they are being treated. The sensors and the cameras viewing the patients can help determine the stress level of a patient. Then, with machine learning algorithms, we can figure out what causes those additional stresses, and then how can we reduce the causes of those stresses.
The faculty can observe each operatory. You can see how the student and the patient are interacting. The cameras make it easier for us to supervise, but in a less intrusive manner.
This is data that was previously not available, and it's being gathered in real time.
Columbia University is one of the first universities to combine dental records with electronic health records.
The goal here is to add the combination of genomics, electronic health record, and the digital data from our environment to provide that unique precision treatment for each individual patient.
So, as you see, this will give us and expand to new approaches for research, such as assisting with the identification of unknown correlation of oral diseases with suspected and new contributing factors, and furthering the creation of new treatment concepts. So, where are we now? Let's talk about some of the artificial intelligence applications that are available now in dentistry. Well, applications in dentistry of AI can be for diagnosis, prognosis, decision making, and treatment planning. We'll start with diagnosis and treatment planning. Well, as you see, we can use the radiography to, we can use deep learning system for diagnosing of different pathologies in X-rays, and it can help us in detection of osteoporosis and classifying of cancerous tissue. In pathology, it can detect the affected cells in digital slides. And it is used also in X-rays as in DiagnoCat or Denti.ai. It gives us a quick report on every tooth, whether it has caries or it is affected by periodontitis. It also can detect precancerous lesions. It can diagnose the TMD as it showed sensitive detection of DMD. In planning, we can use it in digital smile design as computer vision is used in facial recognition and facial analysis, so it can easily detect the patient's features and present the smile that is suitable for that patient. Also, augmented reality can be used with patients that are to see their smile in action. Shade selection is used also, artificial intelligence is used in shade selection. More than 90% of matching accuracy is done, was gained when using artificial intelligence models. In case of implant planning, one of the main problems that faces us is the segmentation of the different anatomy and the different structures while implant planning. So it can automatically, like DiagnoCat, automatically segment and also create a 3D model that can be printed. It can easily detect the inferior alveolar nerve. And one of the things that faces us are the metallic artifacts. It can be reduced using metallic segmentation or using general adversarial networks. When comparing between clinicians and DiagnoCat in treatment planning, there was a study where 75 CBCT images were included. And in these images, bone height and thickness in 508 regions where implants were required were measured by human observers with manual assessment method, and also the canals, sinuses, foci associated with alveolar bone and missing teeth regions were detected. Following all evaluations were repeated with the deep learning convolution neural network, and it showed more accuracy than the clinicians. One of the problems that faces us during our practice is identification of dental implants. And the AI model recognized the implant type with accuracy 93.8 to 98%. Also in orthodontics, predicting diagnosis of orthodontic extractions and assessing the orthodontic treatment, determining the ground development about every stages, analysis, landmarks. One of the things that is used in Soft Smile is in orthodontics is Soft Smile. It is a data algorithm which is created that intelligently decides how the tooth can be moved and how much pressure should be applied as well. And as we said, automatic cephalometric landmark detection can be done using AI. In case of prognosis, predicting of the bonding of CAD-CAM composite resin crowns with AI, and it showed accuracy prediction of 98.5%. Prognosis of implantology, the models to predict osseointegration success or implant success by using different input data varied among the studies, ranging from 62.4 to 80.5%. In treatment, Yuan et al. Described a robotic arm or robotic tooth preparation system with the following hardware: an intraoral 3D scanner that obtain 3D data for the patient target tooth, adjacent teeth, opposing teeth, and teeth fixture, and a computer-aided design and aided manufacture CAD/CAM software for designing the target preparation shape and generating a 3D motion path of the laser, an effective low heat laser suitable for hard tissue preparation, and a robotic arm and a tooth fixture connecting the robotic device with the target tooth and protecting the adjacent teeth from laser cutting, designed using SolidWorks. And as you see, this in the last picture, this is the tooth, and this is the design, and this is the tooth after preparation according to the design. This is a video that shows us how this procedure goes. And of course, this is attempted to give us a more accurate and more precise preparation. They said that the average preparation time of a full crown is 7 minutes, with a shape error range of 0.05 to 0.17 millimeter on its first documented run. Also, robotic arm was used to prepare laminate veneers, and it was more accurate. The finish line was more accurate in the laminate preparation done by the robotic arm. After preparation, we need intraoral scan, and we can use hologram and VR while taking our scans. Also, as Dr. Kienor said, that artificial intelligence is used in our in intraoral scanning, like in MEDIT, that can identify the scan body automatically and launches all the proper information into the CAD software. Three-shape scanning, it removes the soft tissue that we don't need while scanning. Smart margin detection using Pearl.ai. And here's a study that used AI model to locate the margin. It showed accuracy of 90.6% to 97.4%. Also, CAD/CAM uses AI, as we said, using GANs. Where as we said, we have a generator and discriminator. The generator It makes images that our designs that are as accurate, I'll try to be accurate as the technician, and the discriminator sees if it is as accurate as the technicians or not. And here's the result. The crowns produced by GAN are as accurate as that of library, or maybe looks better. Also, 3Shape Automate was used to using artificial intelligence to make us designs automatically. AR and VR are used in implantology, where the surgeon are provided with clear graphical information on the operative side. And here the positioning of the dental implant is made easy by graphically obtained results of the AR.
Yomi's real-time visual guidance works like a GPS system. The surgeon always controls the drill. When the surgeon is close to the target, Yomi guides the surgeon into the precise angle and position. Yomi prevents any deviation from the plan. With full view of the surgical site, the surgeon precisely drills the osteotomy and is stopped when reaching the planned depth. This enables a minimally invasive flat.
This robot is really is semi-automated, but a fully automated surgery was done in China. In the year 2017. As you see that it took less than an hour to install the implant. So the available robots are semi-automated or even fully automated, but not yet involve AI. And only few studies proposed robotic technologies to be used in dental application, and only a minority of the published studies reported prototype systems. Another reason why robotics is still a field of low interest in dentistry may be the lack of expert knowledge to program and control those systems as a non-professional. The research in this domain still relies on the efficient collaboration between engineers and dentists. Also, the use of AI method to autonomously plan tasks and reason about the environment may further reduce the effort on the user side when using a robot. It's used in research and education. Well, augmented reality and virtual reality are being used widely in the field of dental education to create situations that simulate clinical work on patient and eliminate the risk associated while training on a live patient. Also, AI model were used to optimize the implant designs. AI model improve implant designs, minimize the stress at the implant bone interface by 36.6% compared with the finite element analysis models. Okay. And so in conclusion, this study was done with Marta Revela, artificial intelligence model of for tooth supported fixed and removable prosthodontic. Artificial intelligence model have shown the potential for providing a reliable diagnostic tool for tooth sheet selection, automated restoration design, mapping the preparation finishing line, optimizing the manufacture costing, predicting facial changes in patients with removable prosthesis, and also in implantology, AI model for implant type recognition, implant success prediction, and implant design optimization were done with artificial intelligence. So a question, do I have as a dentist to learn programming? Well, we need what is called the clinical AI team. The clinical AI team, it consists of data scientists, machine learning engineer, statistician, and healthcare IT, and us, the domain expert. So, and finally, I have two messages. The first message is to the students. Start learning about artificial intelligence. It's the growing market. You can think of whatever you want and you can learn artificial intelligence. It's AI market increasingly, and some of the AI applications and market. And also there are a lot of startups in of care. Also, there are cloud services that can help you, that you can apply artificial intelligence with minimal code. So anyone can make AI. There are lots of AI providers, cloud services as Microsoft Azure, IBM Watson, TensorFlow platform. And also I'm sending message to researchers. There is a lot of things about artificial intelligence and into our work. So this is the clinical AI ecosystem. What we can now is the training opportunities to create clinically informed engineers and data literate clinicians. And this is what we study in our beloved students. those who can imagine anything can create the impossible, said by Alan Turing. And thank you very much. I hope it was an interesting presentation. Thank you all.
It was excellent. Thank you so much, Doctor. Really appreciated the overview. And it's amazing what we are now able to achieve with AI. So for example, we're now doing 2-appointment dentures, which is amazing because things get articulated in the cloud. It's very fascinating. So it does improve our quality of practicing. It does reduce the uncertainties. Also, patient care is much more predictable. And so you say opportunities. How does someone get started if they want to get more into the space?
Well, we have to start learning. There are a lot of resources that we can use to learn about artificial intelligence. Self-learning is available for all of us. There are a lot of platforms that can help us all to learn about artificial intelligence. You don't need to learn about programming. You only need to know how this goes on, how this works, in order for you to make it to think of the impossible. Okay. Things that you didn't even know about. We don't need engineers to lead us anymore. We need to be the leaders in this aspect.
So learning, you have some societies that you started and that you work with. Where would someone go? I know that Henriette does like the Digital Dentistry Society, and there's a couple of them here in the US. What do you recommend for our colleagues?
Well, you can start with Coursera. They have a lot of softwares, a lot of courses that can help you regarding the artificial intelligence in healthcare. For deeplearning.ai or Stanford University, they are giving us a lot of teaching materials for free. And also Harvard University is providing us with the CS50 program with the genius David Mellon. I myself am taking this course. There is CS50 Python, CS50 artificial intelligence, and also the companies themselves are providing us with learning, like Microsoft. You can access Microsoft Learn or IBM. There are courses for healthcare and AWS as well.
Excellent, excellent.
And I give courses if you want to start with me.
Yeah, sure. I mean, people that sort of establish a rapport with you to this Podinar might want to be interested. So how do they go about taking these courses with you? Is it an online course or?
Yes, we can make an online course for foreigners only, to be in English language. And it can be certified by one of the companies that I mentioned.
Excellent. I would love to talk to you more, especially when we meet in Italy regarding AI and
sure.
Some of the things that we can do there. That would be wonderful. It's very exciting. You got some 200 shares already of this Podinar that I see happening in the background.
Really?
There's quite a bit of interest in this topic. So perhaps you can join us regularly, maybe next year again, to give us some updates on progress. And we would really appreciate it. And I think it's nighttime over there where you are right now, right?
It's 7 o'clock right now.
Okay, very good. I'll let you enjoy the remainder of your Saturday. I really appreciate you coming on, so does our audience, to contribute without any specific agenda, which we pretty much stand for. And we'd love to have you back. It was really, truly an honor for me to finally meet you, and just seeing your amazing credentials to the election committee. It's time for us to meet. I look forward to it.
And I was proud and I was honored to meet you. And I would like to thank you. I'd love to thank you for all your huge efforts to collect us all whether dentists or doctors, and we'll start, I think, to call for engineers now, I guess.
Yeah, that, and somebody's got to watch this AI so don't get smarter than us, you know. So takes takes a lot of doctors to do that. Well, Doc, see you soon, and have a great Saturday. Thank you for everything you do for our profession.
Thank you very much. Thank you. Thank you.
Take care.
It's my honor. Bye.